So again, welcome you all, for this new course, Computer Graphics and Multimedia Systems. This is an elective, department level elective for semester 5 IT students. And let me, tell you the significance of this course from, in fact, IT perspective, because we know that, what is the significance of an picture. And there is a very old saying which goes something like this: a picture is worth 10,000 words. So that is what we have started believing, not only today, but then from like couple of years, or maybe more than 2 decades, it has been realized that when it comes to an interface, it is always better to have a good mix of what we say, what we call it as text and images and animation and video, audio, everything and everything. And then there is a reason behind, because what we call as god gifted thing to humankind is a brain. And the brain, we will not get into the anatomy of this human brain, but then mota mota cheez agar baat karni hai, to what they say is that your human brain can be regarded as divided into two hemispheres. One is left and the other part is right hemisphere. You can call it as a left brain and right brain, and everyone knows that. The left brain basically is meant for looking after the analysis. So everything which is analytical in nature basically is taken care by the left brain, and which involves playing with the numbers, and textual information, and just remembering the formulas, and drawing the inferences, something like that. And when it comes to the right brain, so right brain basically it mainly looks after the creativity. And when it comes to an creativity, I always believe that one way to express your creativity is to draw. And that is the reason they say that if you don't really involve creativity, pictures, the audio, the music, in whatever you are presenting, probably you are not allowing your right brain to play a role. So they say that something like we hardly uses 20% of the power gifted to the humankind by the Almighty, and out of that 20%, we will not be using half a portion, that is in right hemisphere. And that's not good. So that happens to be in significance of the graphics. And as the quote goes by Jefferson, as computers have become more powerful, computer graphics have advanced to the point where it is possible to create photorealistic images. The quote is not very recent. And then for your generation, talking about creating the photorealistic images, basically, I believe no point, because you have the entire bringing up basically, you have dealt with this computer graphics and playing with the images. The bottleneck wasn't how do we make the pixel prettier, it was how do we engage with them more. So more you involve and more basically will be the engagement. And today we are talking about how to engage the potential customer. So that happens to be one of the major reason. And when it comes to the applications on a very faster track, because today's being a very first session, I will not be getting into the details of this. And I believe you people immediately can realize the power of graphics and computer graphics and multimedia. And multimedia, we mean all possible medias involving text, involving graphics, involving images, involving videos, involving audio, and everything and everything. So virtual reality is one of the happening field, and we are talking about making it possible to give a full immersive kind of an experience to the user, where the user is made to just forget that he what is uh, around him or her, and then the user gets immersed totally into a virtual environment, and he will start interacting with the objects which are there in this virtual environment. And this is one of the very happening field. So computer graphics at the back end basically plays a very important role to generate all possible photorealistic kind of and near realistic basically, okay, and the degree of realism is the highest and allow user to believe that this object is actually an object which exists in this okay virtual world. We are also talking about the data visualization gaining an importance, and then especially okay scientific engineering and medical data. And the decision makers, they are not interested to looking after the numbers, but what they want is to visualize the okay the trends and the visualize basically okay the comparative statements in between some significant objects for them to understand what appears to be a trend, for them to predict what is likely to happen in the future. And then this is again basically okay made possible by using the field of computer graphics. Then we talk about education and training, and this is heavily used. You people already have used basically in your first year of engineering computer aided design, and AutoCAD you have used. And normally what one used to draw on a piece of a paper or paper sheet, you have really generated all those graphical objects on a screen by using the AutoCAD okay, software and tool. And it is heavily used in education and training, because again I'm telling you, when we start using and presenting okay the actual graphical model, the understanding becomes really speaking okay very easy. And that's the reason it plays very important role in education and training. Art is nature of what we can say is in ingredient uh, of creativity. So fine and commercial art now it is happening with the help of computer, with the help of computer graphics. And we are talking about graphics heavily used in the field of entertainment, be it the games, be it basically okay giving and special effects in the movies. So image processing is again one of the important application where we have already generated images. The images are already existing, and what we need to do is we need to process the image. We need to do the analysis of the image so that we can improve upon the quality of the image depending upon the requirement. So this is the very goal of an image processing, which requires the the images to be made available. And computer graphics, really speaking, okay, it talks about the synthesis of the images. It means that the computer graphics believes in generating the images, and the generated images or the captured images will normally they go as an input to the image processing module. GUI is again okay very happening field, graphical user interface. And the UX design and user experience, normally we are calling it as and VIMP interface. So it is window icons and okay menus and pointers interface. And if we effectively make use of all these GUI components, so obviously okay what interface you are trying to develop which stands in between the man and machine, obviously okay will allow man to interact with the system in the most feasible and in the most seamless manner. And that is where this again one of the important field is HCI. So it is human computer okay interaction, or HMI sometimes we call it as human machine kind of an interaction. So again the graphics contributes a lot. And typically speaking, if we try to visualize in a very abstract manner how the graphic system will look like, or rather what will be the components of the graphic system. So obviously images, because that is one of the important objective of an computer graphics. Then we will be having an hardware system, input system, output system, and some software. There are many really speaking, but when it comes to an synthesis, we'll be using some. We are right now as a part of this curriculum or the course will not be talking about using the existing softwares like Maya, which allows us to give a very spatial effect, or a Blender. No, we are talking about. We will be rather talking about as a part of an curriculum how exactly we will be generating all these objects and what are the underlying algorithms, and how what basically the algorithms place, and what can be the optimality criteria of all these algorithms, or how we can make these algorithms more optimal. So this in fact will be the part of our discussion. Now, generally we say that an image is regarded as a two-dimensional kind of an picture. So typically speaking, in Cartesian coordinate system, we try to just think about the very first quadrant where the value of x keeps on increasing to the right and y value increases in the upward direction. So this is typically a world coordinate system, or the way we perceive the things happening around, or the way we deal with this graphical system in our day-to-day life, or Cartesian coordinate system, or be it polar coordinate system or a cylindrical coordinate system, whatever. So images are two-dimensional shape. The two axes we will label it as an x-axis and y-axis, and the value of x increases in the right direction, y increases in the top direction. But the matter of the fact is, when it comes to, we'll be also talking about this. Typically speaking, is Cartesian coordinate system snapshot, and we also have something called as a screen coordinates. And most of the time, there are exceptions, and there will be exception for each and everything, but most of the time, we normally, when we start dealing with the computer graphics, we say that we will regard, as far as a screen is concerned, will regard the top left hand corner as the origin. So this point actually is regarded as 0 and 0 in a screen coordinate system, and the value of x increases as we move in the x direction, and exactly opposite to this, the value of y increases when we start moving down. So it's you can consider this as a fourth quadrant of an Cartesian coordinate or a rectangular coordinate system. But the only difference is that in the fourth quadrant, when we start moving down, the value of y goes negative and starts basically decreasing. But here in a screen coordinate system, it starts increasing. So if we consider a resolution of, just taking an example of 640 cross 480, and I believe you people know your generation resolution is how many points we can plot in the horizontal direction, and how many points, pixels really speaking, picture elements, we can plot vertically. So it is 640 by 480, and these many pixels a screen can accommodate. So if someone asks us what can be the coordinates of this, the obvious answer for this is 639, because we start from 0, and this will be 479, and that is how it goes. So screen coordinate system is slightly different. Okay. Now hardware pipeline is a very simple what we can call it as a phenomena. So you have to have an input, and the system will look after the computations, and the output gets generated. Now, when we want to draw a rectangle, the question is, how do we describe it to the computer? Okay, so we need to provide some input, and obviously, okay, if you ask me what can be the input, so I enjoy a liberty of just having an ability to click two extreme points, and then something like this. So if I specify these 2 points, what I want, the utility, graphical utility, if we are trying to develop it, I want my graphical utility to immediately generate a rectangle, with the assumption that we have selected appropriate icon, or we are calling an appropriate function. So the question is, when I do this, how exactly the rectangle is represented internally? So object description that a computer understands. And now when it comes to how basically the computer understands, so you have the two possibilities which emerges. Define a set of points in a 2D space, vertices. So you need to define, obviously, set of points. In this case, even if user is, we are talking about user providing 2 points, let us assume that this is happening in a screen coordinate. So if I say this is 10 and 10, and believe my dear friends, if we start going down, the value of y increases, and obviously, okay, x increases in this direction. This is what we are assuming, or you can obviously treat this as happening in the Cartesian coordinate system also. So if I call this as an 20 and whatever, okay, say that is the thing that I'm talking about 40. So moment these 2 points are provided, we always can, okay, identify the remaining 2 vertices easily. So this remaining 2 vertices, if you ask me what is the x coordinate of this, I will say that the x coordinate will be 20 because it is falling on the same vertical line where this point is also there. And what is x coordinate value of this point? 20. So all points which falls on the vertical line, they will share the same x value, so 20. And what will be the y coordinate value? So all the points falling on the same horizontal line always will have the same y value. So we can make out basically this vertex, and with the same spirit, we will say that this happens to be 10 and 40. So what you need to specify is the set of points or vertices, and given a set of vertices, draw lines between consecutive vertices. This is how basically, okay, we can generate the rectangle. So like this, and this is in fact, okay, this representation is you need to regard this as obviously happening in a Cartesian coordinate system. And if you ask me what is the reason, so you can make out immediately. If you compare these 2 points, you'll find that the y value of the point which is above is larger. So as we are progressing in upward direction, the y value is increasing. So obviously we can say that, okay, it is the Cartesian coordinate system. So you can have a vertex in a 2 or a 3-dimensional space. So you also can, really speaking, deal with a 3 dimensions or more than 3, depending upon, okay, what kind of an requirement arises. So you can have a set of vertices, and we can define out of this what we can say a 3D model also. So if I say these are the 8 vertices, and I'm talking about representing a cube, so I can say that well and good, I still can, okay, connect the corresponding vertices. The pair of vertices, a line is, or an edge is joining, and then joining the appropriate set of vertices results into a 3D model. And not only the 3D model which looks as simple as like this cube, in fact what they say is that it can be extended to any complex and realistic model also. So that is what I'm trying to, okay, convince you people. So in the other possibility, if we talk about, the first one is you need to have a set of vertices, and you need to really connect them with the set of lines or strokes, whatever you can call it as. The other way is called as a bitmap approach. A bitmap is nothing but a rectangular array of bits or pixels mapped one to one with the pixel. So if we regard this as, in fact, okay, something like just for our understanding, I will say that well and good, I can think of having a 2D array of integer type. This is just giving an example, okay, and let us call this as a rectangular kind of an array, 2D array I'm talking about. And what I will do is, out of, let us assume that the screen happens to be, I'm just giving an example of a very small rectangle which falls in the grid of, okay, 4 cross 4. So this is 4 cross 4 grid, and we are interested in drawing a rectangle something like this, like this. Okay. So I will say that, okay, the grid actually is 4 cross 4, and then I will start initializing. So if you look at the first 6 points, I'll be calling this as 6, and 1, 2, 3, 4, 5. This is actually 5 rows and 6 columns, kind of a grid. So I'll say that, okay, the first row happens to be all zeros. So I will put, okay, all zeros there, because I don't want the pixel to be highlighted there. So you can visualize the bitmap going something like this. So we need to talk about the intensity of each and every pixel, and let us assume that it is just black and white kind of a scenario, a monochrome, where one represent a bright dot and zero represents a dark dot on a screen. So if you look at the second row is first point is 0 and the remaining 4 points are 1. So I'll say that this is 0, 1, 1, 1, 1 and 0. And the third row again basically okay, it is पहला 0 है, बाद में 1 है और बाकी दो zeros hai, and okay again 1 and then followed by 0 and so on and so forth. And then what I'm calling it as 0, I will just make use of one different color for you to better understand it. So I'll be using this. So wherever I am putting the dots as blue color, you regard that is a point where we don't want pixel to be displayed. So these points should be set to 0, something like this. Okay. So this is in fact okay, a concept of a bitmap. So bitmap screen is regarded as a kind of a 2D grid or an array, and you need to speak about typically speaking, what should be the status of each and every pixel lying in that. Pixel is a smallest addressable point. So we have a vector display system, which is sometimes also called as a random or calligraphic or a stroke display. So what you need to do is that you need to specify the position, and then from there, that position you need to say that you are interested in giving a vertical stroke. So I will just give a vertical stroke and which should be extended till this point. Then I will give a horizontal stroke the way the painter draws it, and then I will restrict it only to this point, to the point belonging to the vertex of rectangle, then downward stroke, and then again right to left kind of a stroke. So the displays in which the pictures or the drawings are represented as a collection of the strokes basically is called as a vector display system, which means that if I'm trying to represent A, just giving one simple example, let us assume that we have and again a grid, and let us assume that we have a grid of 3 and 4 and 5, 6. So this is 6, 1, 2, 3, 4, 5. So this is 5 cross 6 kind of a grid. And then if I try to visualize in terms of a bitmap, so I will say that for drawing say A, I want all these pixels, let us assume that all these pixels to be highlighted, and the rest of the part of the screen should remain assume the background intensity. So this is how for me the font of A will look like. Just assume. Now this is what happens in a bitmap, and when it comes to a vector display, so we try to represent A by giving the strokes. So first stroke, second stroke, third, fourth, and fifth kind of thing. So a picture is represented by a collection of strokes. In a bitmap, it is represented by a rectangular grid or an array of the pixels. Got the point? So till this point, if you have any question, I'll appreciate.
No question, sir.
Okay. So these are the two major types of system we can talk about, and bitmap and vector display. Okay. So representing objects, one method was you just use the vertex method, define the object as a set of points with connectivity information. So it's just responsible for connecting them, and then the way you perceive the object, you need to connect them appropriately. So you have to have this kind of a representation, and not you are connecting, especially when you aim as a rectangle. You're not supposed to connect the diagonal vertices. But then if you definitely intend to generate a cross on the screen, so you have to obviously see to it that the edges are made responsible for connecting the diagonally opposite kind of an vertices. So this is how the model file for a rectangle will look like. So because we were discussing about how exactly this should be made known to a computer internally, what kind of a representation should be provided for a system to understand, interpret, and generate the object like that. So the one way is to have a file which is called as a model file, or sometimes we also call this as a display file. So display file contains basically the information about the object to be displayed, and the object is represented by the set of vertices and the connectivity information that exists in between them. So with this as a very hypothetical kind of an command or instruction, uh, what we can say is that it is as good as saying that there are four vertices and four edges. So obviously we have these four vertices, and obviously, okay, for rectangle we need to have four edges. Once we do this, then we are saying the first vertex is 7 3, x coordinate value is 7 and y coordinate value is 3. Next is 7 9 14 9 14 3. Okay, then I'm talking about the edges. So this is vertex 1, this is vertex 2, vertex 3, and vertex 4. So the next combination, the four commands, you can say that the first edge should connect first vertex with the second vertex. So it is 7 3 getting connected with basically, okay, 7 9. The second edge will be connecting second with the third, then third with the fourth, and then fourth back to 1. So this is how we can explicitly specify the what we can say, the connectivity information. And believe my friends, as I said, okay, you can visualize a 3D object also as a collection of, typically speaking, set of vertices and set of lines that represent. So if you just look at this, you will find that if you try to get into the, okay, subtle details and minute details of this, you will find that array ye to sab kuch is just a matter of connecting the vertices and having a set of vertices and connecting them. So by using this vector approach also, in a very reasonable way, we can generate a 3D object, and that is what I'm telling you. Sometimes there is a practice of calling this. You might have come across this kind of an terminology. Okay, we prefer to sometimes call this as wireframe kind of an model, where a picture is represented as if it is a mesh of a wire. So this, in fact, we can regard this as a mesh of a wire. So it is typically speaking in wireframe model. Input devices, there are many, and you people right from your childhood, I believe you have played with them. So when it comes to a locator device, you sometimes during enjoying the game, you might have used the joystick. You might have used, okay, what we can say, the, the possibility is less, but the tablets, yes, tablets we are using, okay, digital tablets. And in fact, due to this unprecedented circumstances imposed by COVID, in fact, we are also using this, okay, digital tablet for, and what right now I'm generating in stroke basically is using that, okay, tablet itself. So you have a mouse today used very much as a locator device. So you can keep moving basically, okay, the cursor, and wherever you want you can, okay, pick it up, and you can make use of a light panes. You have ample number of the myriads of devices available. A tracker ball is there. Okay, so these are few as far as a locator devices are concerned. Keyboard is a very old input device, and the most what we can say, the most oldest one, and the most fundamental input device happens to be the keyboard, and still we are using it. Even the virtual keyboards are available, but then we still uses basically the physical keyboard. Scanners are there. Okay, scanners you can really digitize all possible images, text, documents, everything. And then we have different types of scanners, and then we have laser scanners also. We have printers, and from line printers, dot matrix printers, which possibly has gone obsolete, and your generation knows basically again inkjet and laser printers. And to that extent we are also talking about the 3D printers and cameras used heavily for capturing the images. So once this input is made available, so we have a model of what we want to draw. We already have discussed कि कैसा आप represent कर सकते हैं, which goes inside the computer to generate the output. And the computation will be by using the transformation. Transformation is just bringing the changes. Okay, to convert something into something is a transformation, or a rasterization. Rasterization in fact is a process of converting the definition of a graphical object into the set of pixels using which the graphical object can be represented. If you ask me about typically speaking, okay, of about this, so rasterization ka one example is, if I ask you what all information we will need for we to think about a line segment. So we'll say that sir, two vertices v1 and v2, and we need to specify in a 2D reference frame, we need to specify their x and y coordinates value. So x1 y1 and x2 y2. So this is how we define a line segment. But then rasterization is a process of understanding for generating a line in between v1 and v2, okay, which all pixels on this straight line path should be highlighted. Okay, so which basically are the pixels which falls in the along the straight line path that exists in between v1 and v2, and then what should be the pixel color. So this is in fact a rasterization process. So we'll be talking about lot many algorithms about the rasterization. So computations, and then we do the transformation. Why transformation is required? Because okay, we just now have come across a basic difference, because in a Cartesian coordinate system the value of x increases in the right direction, value of y increases in the upward direction. And in a screen coordinate, if we talk about, the value of x still increases in the x direction, but the value of y probably okay goes increases in the downward manner. So we need to bring those changes. So once the model is available, the model is required to undergo some kind of a changes transformation. The transform model is provided, and the rasterization takes place, and the output gets generated. So that is how it goes. Okay. So the reason is that when we talk about rasterization, जो हम लोग बात कर रहे हैं कि भाई हर एक पिक्सल की इंफॉर्मेशन रिकॉर्ड करनी पड़ेगी, तो सवाल रहा कि ओके मेमोरी कैसी एलोकेट होगी, तो मेमोरी तो लगेगी कि लगेगी. एंड दैट इज द रीजन ओके देयर इज टिपिकली द बेसिक typical computer graphic system okay talks about you need to have kind of what we can say, a kind of an frame buffer or memory. Really speaking, there is a practice of calling this as a frame buffer, or sometimes we call this as a refresh buffer. Is a part of a random access memory, RAM type portion. Your generation may be calling this as a video memory, or what we can say, a picture memory, or display RAM. Okay, probably you may be familiar with this terminology. Okay, and especially those who are crazy with the gaming, they know the importance of this memory, because okay, a normal laptop or a desktop will not be supporting the special effects which nowadays we try to enjoy when it comes to an okay this gaming zone. So what we want is that we want some graphic accelerator card which is equipped with a high-end graphical processor, and also equipped with an additional memory of something like an 4 GB and maybe an 8 GB. Okay, so that all the graphical related stuff can be taken care by this graphical processor. So that is a frame buffer we talk about. And what goes inside and then what comes outside, and then this is fed to the display device, something like this. So frame buffer is a space where the details about what should appear on a screen should be recorded. So a block of memory dedicated to graphics output that holds the contents of what will be displayed. And then it is something like, okay, for every pixel the intensity details will needs to be made available in the frame buffer. And what is pixel? Pixel is one element of the frame buffer, or pixel also can be defined as, pixel is, it is smallest addressable point that exists on a display. And we are saying smallest addressable ka matlab hai, we are trying to say that this smallest point has its own identity. So we can refer to a smallest point by saying that this part of an frame buffer should be set to this color, that kind of an, okay. So as I already have said that, okay, if we consider a resolution, or now if you ask me what is resolution, so resolution talks about maximum number of pixels that can be displayed on a screen without overlap. So we don't want the pixel to lose upon its unique identity without overlap. So if I give again the same example, let us assume that it is 640 cross 480 kind of an resolution, and now you're talking about an 4K ka resolution. Okay, so the technology has reached to that level. So high definition and very high definition. But then just right now for me to give an example, if it is 640, so we are saying that on a screen we can display 640 pixels in a line, and we can display such 480 pixels in a vertical manner. So altogether how many pixels can be displayed? 640 into 480 number of pixels. So this becomes a resolution. Okay. So how big is the frame buffer? What is the largest image you can display? How many pixels are there? And how much memory do we need to allocate for the frame buffer? So when it comes to the frame buffer, you always will wonder, and you will always basically, okay, have this sort of questions. If we are trying to display certain image, whether the frame buffer really will impact the size of the image what we are trying to, or whether what we are aiming at will have an impact on the size of a frame buffer. So how big is the frame buffer? It all depends upon how much of a memory is set aside for the purpose. Then what is the largest image you can display with the given information about the size of frame buffer, and how many pixels are there, and how much memory do we need to allocate for the frame buffer? Now it all depends upon. So my dear friends, okay, we have different ways of organizing a frame buffer. So frame buffer organization की अगर बात करते हैं ना, तो it is as simple as like this. Listen carefully. The simplest case is what we can say monochrome display devices. For example, sorry, black and white. display devices. So in this case, it is very simple. If you are trying to have this kind of an image, a dot is where the pixel needs to be displayed. So in this is an image, a picture to be generated. So इसका corresponding frame buffer. Right now we are not talking about okay उसका size. Just I am giving an example. So frame buffer के अंदर जहाँ जहाँ पिक्सल डिस्प्ले होना चाहिए उस पॉइंट के लिए 1-to-1 correspondence है. Every pixel will have one corresponding bit lying in a frame buffer. And we call this organization as 1 bit per pixel kind of an organization. तो जहां जहां पिक्सल को डिस्प्ले करना है वहां फ्रेम बफर में अपने मेमोरी में 1 रहेगा और जहां नहीं चाहिए वहां 0 रहेगा, something like this, and this will be all zeros. This is a very simple scenario, but now when it comes to typically speaking RGB display devices, so RGB stands for and red, green, and okay, blue. So common sense, more of an common sense. Then, if I show you, if we think of 1 bit per color per pixel kind of an organization, इसका मतलब हर एक कलर के लिए एक एक बिट रखा जाएगा. So my dear friends, if we just consider this kind of an possible combinations, you tell me if the bit meant for R, if the bit meant for G, if the bit meant for blue, all of them they are 0. So obviously इसका मतलब है this is a black color, no color will contribute. And इसका extreme is कि सारे colors अगर equally contribute करते हैं 1-1-1, so this will be the darkest and not darkest, sorry, brightest. So we can call this as a white. However, in between these two extremes of black and white, if I say let us consider 0-0-1, so you'll say that sir red bit is 0, green bit is 0. इसका मतलब green का भी कोई contribution नहीं, लेकिन blue bit अगर 1 है तो इसका मतलब है जो color हमें screen पे मिलेगा वो blue color मिलेगा, and similarly rest of the things. So एक 1 bit per color per pixel. तो इसका मतलब है कि for every single pixel, this implies for every single pixel in a frame buffer, we need to have 3 bits. आप पूछोगे मुझे 3 बिट्स क्यों, तो मैं कहूंगा 3 बिट्स इसलिए ये 3 में से एक रेड की बात करेगा, दूसरा ब्लू की बात करेगा और तीसरा बेसिकली ओके ब्लू की बात करेगा. सो इफ अगेन if we have a color image I am talking about, and then अगर हम लोग ग्रिड की बात करते हैं like this, और मैं एक दूसरा एग्जांपल लेता हूं जहां मेरा काम आसान हो जाएगा. So if I say that this is this point I want to be displayed with a red color, okay, and this point I want to be displayed in a blue color, sorry, green color, and this point I want that to get displayed in a blue color. तो इसका corresponding जो frame buffer रहेगा, फ्रेम बफर की साइज ऑब्वियसली बढ़ेगी. So we have 4x4, so it becomes like this. तो ये जो पिक्सल है अभी, प्लीज लिसन केयरफुली, आई एम यूजिंग इंटेंशनली डिफरेंट कलर नाउ. ये वाला जो पिक्सल है, ये वाला पिक्सल, वो एज्यूम कीजिए वो ब्लैक है, बैकग्राउंड इंटेंसिटी है उसका. ओके, दिख रहा है आपको, आई एम टेलिंग यू, वो ब्लैक है, ऐसा बैकग्राउंड इंटेंसिटी है. तो ये पहला पिक्सल के लिए ये 3 बिट्स रखा जाएगा. These 3 bits will correspond to this single pixel and all of them will be set to 0. उसके बाद वाला जो है ये वाला, that also is black. So the next 3 bits का chunk again will be set to 0. So will be the case with the remaining 2 possibilities also. 0 0 0. लेकिन और वापस ये भी 0 0 0. अभी लिसन केयरफुली, ये वाला जो पिक्सल है ना, उसका ये रिप्रेजेंटेशन है. अभी उसके बाद वाला जो पिक्सल है, ये दिस इज रेड इन कलर. तो यहाँ आपको दिखाई देगा द 3 बिट्स विल बी आरजीबी है, तो रेड कलर विल बी सेट टू 1 एंड बाकी दो का कॉम्बिनेशन 0 0. इसका मतलब only red will appear, the pixel will only assume the red color. Then the next will be a green color, so RGB, so 0, this will be 0 and 1 and 0, and last will be a blue color, so this will be 0 0 1. That is how it goes. So this is called as an 1 bit, and then you can have more number of bits for every color. So your capability, assuming that the hardware supports it, so obviously, okay, every pixel will start assuming more and more number of colors. So that is how the frame buffer organization goes. So till this point, if you have any question, you can ask me. Siddharth and Piyush.
No, sir, no question.
No question. Okay, Siddharth. Yeah. Let me talk to, okay, the co-host. Vaibhav is there. Vaibhav है? कौन है? Just give me a okay. Give me a minute. I will resume again. Just give me a minute. So Piyush and Siddharth, am I audible?
Yes, sir.
तर तेच कारण काय की आज तुम्ही दोघंच आहात, म्हणजे आय नो despite of the importance of this subject, but then other two subjects I know are also maybe close to you, easy for you. That may be the reason, but then we are assuming that the students also will realize this being a very first session and the very first week. you may okay, possibly will do some kind of an survey and research, and then may decide okay, to join this course also. I think for today's session, this being a very first session, the introductory, and this is very simple, interesting also. So I assume that better we close the today's session here itself, and if we get a good response, definitely we'll be starting okay, next time we'll have more interesting discussion. So thank you for being with me, Piyush and Siddharth. Love you guys. Thank you.